Hi, everyone. Thank you for tuning in to this year's edition of the Cooling Tower training. Appreciate everyone being able to make the sacrifice to be able to do this all 100% online as opposed to in person, but I think everything we do, every little bit we can do to maintain that social distancing should help. Anyway, so let's get started with the slides. I wanted to start off as a give a broad overview of why we treat cooling towers in the first place. There's really four areas that we try to address when we're talking about cooling tower chemistry. The first, obviously, corrosion. Mild steel and water is not great together. Scale. There's a lot of minerals dissolved in the water that can plate out and inhibit heat exchange efficiencies. Then there's sludge. Cooling towers are huge air scrubbers, really. The 100-ton cooling tower, which is not very large, can scrub the air of the Metrodome in a 24-hour period. So quite a bit of dirt can get into this water, which can also provide a lot of food for the last one, and probably in this context, arguably the most important biological growth. These bugs, not only are they it's a health and safety issue with Legionella specifically, but it's also very costly to have biological growth in your tower. So starting off with the types of corrosion, the first thing on why we treat cooling towers is there's about five types of corrosion in there. There's uniform corrosion, which is really just generalized everywhere, dissolving the metal, dissolving. There's white rust, which is specific to a galvanized system. So white rust refers to the zinc oxide that actually forms, and it's a very distinctive white color. It's when you don't passivate towers and when you're not treating towers properly. There's pitting corrosion, which is a form of localized corrosion. I think most the engineering staff here is familiar with pitting in boilers, but in cooling towers you can actually get it as well. Specifically, if you have under deposit, is really when you see it in cooling towers. Galvanic, dissimilar metals. If you put copper and galvanized steel threaded into one another, you will see some galvanic corrosion. Aluminum is a big one that you'll see will galvanically corrode, and that's just dissimilar metals connected by a ionic solution that helps. You actually create a battery, is what you do, and it dissolves away. And then the last one is the microbiologically influenced corrosion. This is literally bacteria forming and trying to eat all the metals around them, which can be pretty localized and pretty dangerous, in addition to being a safety issue. So going on to the second issue is scaling, the mineral content. Most notably, calcium carbonate tends to scale out first, and it's not the only one, but it's definitely the most common and abundant mineral that this scales out, and it's really determined by three things. One is the actual concentration. The more concentration you have, the more the water wants to scale out and deposit onto surfaces. Temperature is the second one. The hottest temperature in your cooling tower system will be the first place it starts to scale out. For these HVAC system, that is your condenser bundle. That is the hottest point in there. If you get really intense scaling, really oversaturation, you'll start to see scaling your fill as well. And then pH, we don't do much for pH adjustment, but this is the theory behind acid feed. The more you lower your pH, it reduces the amount of scaling that can occur. So when we start talking about scaling on a more how do we do it, we use what's called the stability index calculator. And this is calculates the ratio of conductivity to your alkalinity to your calcium hardness at a given pH. And it'll tell you what's called the Langelier index number, the Reisner index number, on how likely it is for scale to precipitate out. And this is how we design our programs. This is why we chose 1,000 conductivity, because it correlates to a specific alkalinity and calcium hardness level on Detroit city water. But this is what really goes in. The most important thing here is that the more minerals you have in the water, the more likely it is to scale out. So bleed becomes very important, as we'll talk about in a couple slides. So why is scale bad? It reduces your chiller efficiency. You can actually scale a system such that you can't even meet your cooling demand. if we're a given building, you'll get hot calls on it. It'll foul up your cooling tower fill, which again will reduce its efficiency. It's got to run. It's got to run harder. And you can see on this fill in particular, the biogrowth on it scale provides housing for bugs to grow in. And again, lower cooling capacity just as an overall issue. So how do we control and make sure that we don't have scale in our systems? Well, the number one way we do this is actually bleed. And what this is drawing off some of the tower water so we can dilute it with fresh makeup that tends to be at a lower mineral concentration. It dilutes it, prevents those minerals from coming out. The way we do this is we control conductivity. The more minerals you have in your water, the more conductivity it actually has. The more ionic the solution, the more the ability for it to conduct water. So it's a very cheap but effective way of measuring mineral content in there. And then the bleed amount is dictated by two things: your water quality. The more minerals you have coming into your tower, the more you actually have to bleed, the higher mineral content. And then the system usage. You know, Thompson Home just doesn't have as much bleed as the chemistry building. It's just a much smaller tower. And then from a chemical standpoint, what we add is what's called a scale inhibitor. Our low core series moving to Monatrol series. More on that in a little bit. But you basically add a chemical in there that has polymers that binds with that calcium carbonate I talked about earlier and prevents it from sticking. When you bind with these crystalline structures, they just can't get a good grip on the surfaces, so they stay in solution and then are bled out when they're bled out when the cooling tower blows down. So how quickly does the scaling really occur? Well, very quickly, especially on these very low water volume systems that don't have much buffering capacity. And Detroit City Water has about a pound of scale per 1,000 gallons of makeup that go into these towers. And these cooling towers use anywhere from 500 to 60,000 gallons a day. So that's 60 pounds of scale forming material that could enter one of these systems a day. That's quite a bit. So the biggest thing, like I said, overcycling, can't stress enough how proper bleed control is. And it's got to be automated because the scale occurs very quickly. If you lose that bleed valve, it can happen very rapidly. And it's also why manual bleed, just opening up a valve, is very difficult to control because the moment you hit that, if you set that valve for an 80-degree day and then it goes up to 95, well, you don't have enough bleed anymore. And then you can actually scale out the tower that way. And then high heat exchange temperatures and then low inhibitor, as always. So how are we currently addressing this from a chemical standpoint? These are the low core 2000 TF and the other 2000 series. Those are your corrosion and scale inhibitors. AquaClean ODP is a biodispersant to make sure that your Sta-Brom 909, your oxidizing biocide, can work better. And then we last year introduced a non-oxidizing biocide, GAX 26 or Promax 1.5. It's called isothiazolinone. I'm going to refer to it as ISO because that is quite a mouthful. So this is what we're doing now, but it is actually going to be changing. So Eldon Water was recently bought, not recently, in the last year, was bought by DuBois Chemicals. And we're going to be switching over to the DuBois Chemical line. I think as engineers, you'll find them a little bit more user-friendly in the sense that everything is PTSA traced and everything is pretty much more concentrated. So you have to change out the pails or the containers much less frequently. So we'll talk a little bit more about that. So now that Eldon Water is going to be transitioning to DuBois Chemicals, there are a couple things I want to point out here. This table will be available to all engineers in the startup documentation, and it'll be posted in the stockroom. Linda already has a copy of what the conversions are, but there's a couple things I want to highlight. I'll start with the corrosion scale inhibitor. So the low core products here, we've had a number of them on campus, but they're going to be concentrated into one. They're going to be going to Monatrol 2302. And they're all going to be PTSA traced, so it's all going to be the same testing method. You're not going to have to use molybdate for 2100H or TM, so it should be quite a bit more streamlined on your testing. Plus, it's more concentrated. It's about 30% more concentrated, so it will go a lot longer. Biodispersant AquaClean ODP will be changing over to CW878L. I know it's a great name, but it is significantly more concentrated, and this is about 50% more concentrated. So just making sure that it goes online, and if when you change out, if you have AquaClean ODP, we'll talk about the procedure, but the pump settings are gonna have to go down quite a bit. So you're gonna have to talk with Eldon Water DuBois when you change this one out specifically. Our bromine product, Sta-Brom 909. We're actually going to be going over to what's called Trekside 323. This is the DuBois product. This one's about 30% more concentrated Sta-Brom bromine. It's the same actives. It's still a stabilized bromine mixture, but it's just more concentrated. Non-ox or isothiazolone. I think, folks, this one's been the difficult one because the last year, March, that plant explosion really put a dent in the supply line for this chemical. And COVID-19 did it no favors either with some of the trade being shut down. So we have secured a good supply line of it, but it's going to be mostly Promex 1.5, GAX maybe later, but please just recognize that this is ISO completely, these two chemicals, and just I would almost refer to them as ISO. Just so you know what you're actually putting in there. And then chlorine. So we're actually going to still be having some towers on chlorine this year because we were getting really good results on them last year. So we don't want to take them off this year on it. There's about 7 or 8 towers. And again, Trekside 311 is the nomenclature for Halochlor C. Really pay attention to this 311 part because it's very similar to the Sta-Brom. You don't ever want to mix these two together. There will be a small explosion. It will not be fun. Just kidding, but don't mix them together. So please pay attention to labels with all these chemicals and understand exactly what you're putting on. The label matches. If there's any questions, reach out to Eldon Water or OEHS, and we'll make sure, or your ADs, and we'll make sure that things are transitioned properly. Just to reiterate some of the points I was making on the last slide was Monitrol 2302 replaces all low cores and is PTA tracer test. That means you use that handheld meter. You don't need to mix up any chemistries for it. Yeah, it's just a much cleaner and simpler test. The control limits are the same. Monitrol, CW8, CW878L, and Trekside 320 are all more concentrated. So there will be adjustments to the pump settings. When you change over, you have to contact Eldon Water, and I will tell you what the new pump setting is, the conversion is, on a more exact level. But please give me a call, send me an email. Do not put it on if you think you're going to run out, really soon because you only got quarter of a pail of ODP on there. Give me a call. Let me know. Again, you'll know real quick with Monitrol and Trekside 323 if you're overdosing because you're testing for those daily. But CW878 is much more concentrated, and actually your tower will start foaming like crazy if you put it in at the same rate as ODP. So unless you want calls for a foaming tower, which I don't think anyone does, definitely make sure you reach out to Eldon Water to make sure we get the proper pump setting. So just as a reminder for the tower program as a whole, we're having bromine ISO as your biocide programs. Again, the nomenclature on the ISO. Automated controllers are going to be online connectivity, and we're going to have biocide pump flow meters to help you track your biocide usage. We're going to be testing for halogen daily on the cooling towers for total chlorine. And again, just overall increased response. This is just changes from years past. Anyone who ran this program last year should be right at home. So for the biocide dosing mechanisms, I think it's important to understand the differences between the two. So for your ISO products, these are shock dose products. That means a traditional bolus or Again, just bulk feed at a given point twice a week, actually, Monday and Thursday mornings at 9 o'clock in the morning are when these are scheduled to dose for 32 ounces per 1,000 gallon system volume. And I lock out the bleed too, because what it does is it prevents the water from diluting the ISO in the cooling tower water. So you want to lock out your bleed. The bromine, your Trekside 323 or Sta-Brom 909, that is continuous feed. It's going to be meter initiated feed and then a daily dosing on there. So what that daily dose is anywhere from every morning about for 5 minutes. It's going to dose 5 to 15 minutes, depending on the size of your tower. Larger towers need longer time. It'll be dosing automatically. That will help you maintain residuals in the shoulder seasons when you really don't have a whole lot of makeup. And just make sure you have fresh bromine going in there every day. And then we'll talk a little bit more, but we're going to have 2 bromine programs, a standard one, your 1 to 2 ppm total chlorine, and then 2 to 3 ppm for your elevated programs. I'll touch more on that in a little bit. The automated controllers I talked about, very similar functionality to some of the older controllers we've been using. Pump sensors will put out daily usage. Those are that gray things on top of the pump there, and it resets at midnight every night. And then it will email alarms to AD Engineer and Elmo Water. I'm sure many of you are familiar with it, but you can actually see what it looks like, the daily dose. Ignore the glute there. That'll be ISO. The daily dose, again, resets at midnight. For the halogen testing, it's going to be daily. We're going to be still doing daily testing. This is very helpful to make sure we were maintaining proper results. And we're going to be doing the color wheel again. I know there are pros and cons to some other testing mechanisms, but we're actually trying to keep between 1 and 2 ppm, this is the right method because the resolution is 0.2 ppm on this color wheel, and you can argue between 1.4 and 1.6, but the reality is you're still in range. My biggest fear is getting it too low, which the electronic meters can actually artificially read high. So I do believe in using your own eyes to test the halogen for maintaining these levels. With testing, we'll talk a little bit more about the specifics of it, but just remember we're reporting it in ppm Cl2. That's just how halogens tend to be reported. You convert the bromine to equivalent parts chlorine. That's just how halogens are reported in general. If you remember from the periodic table of elements, fluorine, chlorine, bromine, iodine, those are all halogens in there, so they're at that same class, but we always convert our parts of bromine to chlorine, even though we're using bromine. With the chlorine testing, really, really important. Make sure you have clean glassware. We're going to be trying to have replacement test tubes in the stock room if yours have gotten sullied or dirtied up from last year, just using them last year. But rinse, triple rinse, and fill up your control with empty water, and then place in the color side of the comparator. I believe that's your left side. And then fill another one, the second one, with your 5 milliliters of water and add your powder reagent. Be very, very careful and make sure you know if you're doing total or free testing. It can be very hard to say. You have to look very, get your readers out, get your magnifying glasses out to make sure that's what you're doing. Double check your packet, but you will get a low reading if you do the free chlorine as opposed to the total halogen. So once you've added your tiny packet to the 5 milliliter sample, you let it wait for 2 minutes so it can fully develop. When you add it into your the color comparator, again, you then throw it in the color wheel and you turn until you see the resulting ppm. That's the number that you change out. Again, very trying to make it a little bit broad range. I know the resolution is not amazing on these, but it is pretty simple. If there's any issues with any of this, please let me know. So what happens if you get a low result or a high result? What should you do? There's really two lines you can take depending on what program you're running. I mean, it's the same things you do, but just depends what program you're running. If you're running the standard program, right here, your control limits are 1 to 2. This is 25 towers on campus or so. Beth has that list distributed in our startup documentation if you're unsure of which ones are which. But if you're low, you check pump, make sure it's not something silly like the pail is empty, or you just didn't check prime on the pump. If you confirm that's what it is, that it wasn't one of those things, and it's just low, you just raise it by 10%. And then you email your associate director in Eldon Water via the email. Comments on the logbook are not sufficient for this. Just want to reiterate that. And if it's high, reduce it by 10%, and email the associate director in Eldon Water. This is just to document, make sure that we have everything in a row. And for the elevated program, the exact same thing. It's just different control limits. We're trying to hit 2 to 3 in there, so your bromine settings are going to be a little bit higher. But again, checking the pump, raising the stabrome, and then emailing the AD and Eldon Water. Really want to document this. This is so we can have a comprehensive water safety plan, because this is part of our corrective action workflow. If you remember from the ASHRAE 188 standard training, a lot of that standard says you have to document things, and that's what a lot of this is about. So that's why we have that third email step in documentation on these. And if things weren't fun enough, we do have a chlorine program. Some of the buildings really did have, we struggled with last year. And so we were actually running a supplemental chlorine with the bromine and the GACs and the biocide program. This was really to make sure that we had non-detects. Very difficult to do in cooling tower systems on a consistent basis, but boy, were we throwing the kitchen sink at it. And these programs are a little bit different in the sense that your bromine's meter initiated, but your chlorine's ORP controlled, and that can make some control issues. But it's really important to know that you're just going to be testing for the bromine and the chlorine, but the adjustments to the chlorine will be made by Eldon Water. You have to test both free halogen and total halogen, so make sure you have packets. If there are any questions on this, on what the distinction is between free and total, please reach out to me. And from a response mechanism, it's very similar to the other ones. We'll only be responding, the engineers will only be responding to the total halogen level, and it's 1.6 to 3.2. And you're just going to be controlling the stabrome. But these are a little bit harder to control. If you're running a chlorine program, please talk to me. It's important that I'm familiar with what's going on, because these two, chlorine and bromine, do overlap in some of their testing mechanisms with the free and the total. Just please make sure if you're out of range in your results, you're contacting me and letting me know. More testing on dip slides once a week, Monday morning. Please take a dip slide, and just some best practices with this. Don't touch anything other than the sampled water with the dip slide. Any bacteria in your hands, surface, you lay it down on the table, it will completely screw up, and more often than not give you a much higher reading than is accurate. Submerge the slide in the water for at least 3 seconds. So when you fill up that little vial that it comes in order to submerge the dip slide, hold it in there for at least 3 seconds. It says up to 15 seconds, but at the very least 3 seconds. And make sure when you allow the excess of water to drip off, it's kind of that uniform film across that dip slide. Put it back into the container and then open it a quarter turn. This is to help prevent excessive gas from building up. Again, a little quarter turn. And then mark the location and the date on the slide. And then wait a minimum of 48 hours to record the bacteria count. And if it's high, retake on Wednesday. But you can see the charts here. We are rounding up. Sometimes you'll get something that's in between there. You know, a couple more little red dots there. Round up. We're gonna be rather be safe than sorry this year. As far as entering the dip slides into the logbook, there's a little bit of a trick here because what we have to do is we have to make sure that the logbook entry is associated with the date it was taken. So if I take a dip slide today and then enter in a log 2 days from now to enter in the dip slide, well, that log 2 days from now is not going to be like it'll look like I took that dip slide 2 days from now, which is not representative of the water today. So you actually have to go back to the log and enter in what you got on that log. So how we do this is when you enter your log in for on your Monday, is you actually mark it as sampled, and that'll let the logbook know that hey, something was sampled but it just hasn't developed yet. So it's a little drop down menu. You just hit sampled on it. Okay, and after 48 hours, you go back to that log that you took on, today, the 24th, right? You go back to it and you put that drop down menu and you click what it is to the best of your ability. We're rounding up. There's a or a less than 10,000 option. Don't choose that, please. That was that's hard coded in there for some other customers. It cannot be removed, but for Wayne State it is not applicable. If that is chosen, you will be the Water Safety Committee will know about it and ask about it. So please don't use 10,000. So it kind of convolutes the data and makes the data a little bit harder to analyze, which is actually a big part of what we're doing. We're trying to understand and make sure that these programs are in compliance, but less than 10,000 can screw with the data points that we have up to this point. It's not so much that it's inaccurate, it's more that we've been collecting data for years on a certain scale. Adding a new variable at this point really messes with some of the data that's been generated and some of the conclusions, so we really want to avoid that. If there's any questions on that, please let me or Beth know. From a testing schedule, same as last year, connectivity, tracer PTSA readings, total halogen, free halogen as well if you have a chlorine table. And then the chemical inventory, the chemical remaining in pails on site is really important. This will help us get inventory to you if there's a stock out for whatever reason. If the world shuts down with COVID-19, I mean, it was literally a Chinese plant explosion last year, and it's a pandemic this year. I mean, I think the force majeure on Wayne State is there. So anyway, tower status: are you offline running or drained? And then any pumps that any changes. You don't have to log your pumps every day, but if you make a change, please log that in the logbook. It really is helpful when we're doing the troubleshooting process. And then at the very least, you can do this daily, but very minimum weekly, your makeup water, your water meter reading. Again, just from an energy efficiency standpoint and a conservation standpoint, really important to do this. But it also helps a lot in the troubleshooting process as well. So thank you if you can do that. Beth will be talking about some tower startup issues with her training. Just a couple of reminders: towers got to be cleaned before they're put online. That sludge factor, that dirt factor, really important in running a proper program. She's got the documentation. It's a lot more in depth on the full startup guidelines. My expectation, my ask of you is be comfortable with it and ask if you need any help. If you've never done it before, or if you're unclear, if you're out of ODP and you have to use a new chemical, please just call me. If you want in-person training, please just let me know. We'll get something set up. We'll get something figured out for the season. But really, just can't stress enough. If you're not sure, ask, and then we can get you the resources to get the tower started up properly. And then finally, just some miscellaneous things I'd like to talk about. Inventory on site is 1 month is reasonable what we're trying to do. I know sometimes it's hard, but at the very least, an extra Paleo Bio side. Just God forbid, Friday, something goes on the weekend shift, you just want to make sure that you have that extra pail, that safety blanket there of the bio side. Another thing I'd like to stress is just if there's issues with the program, please let us know. The program requirements have definitely increased over the last 2 years for good reason, and the entire market has changed. The regulatory requirements are just a lot more than they were, but that doesn't mean we know exactly the most efficient way to do everything. So if you think of anything, please speak up. It's really, really helpful. I do appreciate your feedback for sure. ORP values would be ignored. We're only going to be replacing ORP probes on chlorine program towers. So every tower has an ORP probe. You will get a new one. I will be replacing a new one if you have chlorine feed on there this season. Otherwise, just make sure the probe is back in there. The old probe's back in there when you put the controllers back together. If there are any questions on the ORP stuff, please let me know. But really just make sure the probe is still back in there and when you turn the tower controller on for the season. And then finally, if you're at X-Ray 188 training a couple weeks ago, document. That is the name of the game here. Use your comments to expound on issues. That is like when we go back and look into the things that happened, the engineer comments are critical and arguably the most important piece of data if there's an issue. So please document as much as possible. So I just wanted to thank everyone for tuning in. And, like I said, can't stress this enough. Please just reach out if there are any questions. I hope I was comprehensive in this online training session. But if I miss anything, please reach out to your ADs, reach out to me so we can get a Q&A document. We really want to distribute answers to any questions this year and just make sure that all issues are addressed prior to, the 70-degree, 80-degree day that comes out of nowhere in Michigan. So thanks again, and I will see you guys around campus.